Thank you. All right. So hopefully everybody's enjoying the conference so far. We're almost done. Hopefully everybody, had a good lunch. We'll see if everybody stays awake after this talk. I know, building software is super exciting and everything, but my name is Chris Morrow. I'm a staff software developer here in Austin, Texas. I work at a company called Q2. And over the pandemic, I was working on some open source software called Build Magic, so I'm here to talk to you about it today. So we'll go over some issues with building software, what Build Magic is and what it can do for you, some common build problems, and then go over some examples. So, okay, if you're here, you're probably interested in writing software, or you do this professionally, right? But we don't think a lot about building software. That's boring, right? And often it's extra stuff that we have to do in addition to writing our code. So let's go through a little example here. So we have a software developer. His name is Brian. So Brian likes Python, and he works on a side project where he creates a little Python application that saves him time and also saves the company money. So this is great. And other devs on his team want to use it. So Alex is on his team. She is also a Pythonista. And Brian can simply just send it to Alex, and everything just works. So Brian's getting more recognition for this within the company. And then Brian's boss's boss, Ellie, wants to use Brian's app. Well, Ellie's not as technical, and she doesn't want to install Python, and she is using Windows compared to the rest of the team, which is on Macs. So Brian's thinking about, how do I solve this problem? So he reads about something called PyTexas. He's like, oh, okay, let's give this a shot. So first thing he realizes, though, is that PyTexas only runs on Windows. So he goes to the IT department and gets a Windows laptop and is like, all right, let's do this. Then he realizes, okay, well, now I need msvcr90.dll, and I can only get that from Visual Studio or this Microsoft Visual C++ redistributable. So, and he's wondering, what is the newest thing here? Because a lot of this info is old. So Brian decides to install Visual Studio and manages to get this to work. It spits out a directory that has his Python application now as a Windows executable, along with some other files. He sends it to Ellie. It works. Everybody's happy. So the thing, though, is this is all dependent on a laptop, and now the whole company wants to use this. So Brian goes and automates this with GitHub Actions, and then uploads all the artifacts to Artifactory. All right, so what are our takeaways from this? So we can, by looking at this, we can see builds, can quickly become complex. Also, in this example, Brian had to build for multiple platforms and create separate artifacts for those platforms. But also, I think something we don't consider that often is that build processes evolve over time. So keeping all of these things in mind, I developed Build Magic in late 2020, and based off of some things I was doing at the time. And I describe it as an unopinionated build automation tool. Also, one of the key facts here is it ideally should be producing reproducible and portable build jobs. So it's doing this through abstracting away where the commands run from the underlying environment. And I'll talk some more about how that works. So another key feature here is that each command you automate runs in its own shell process. You can run everything from the CLI if you really want, but if you want to batch stuff together, there's a simple, approachable YAML format for doing that. And it runs on Windows, Mac, and Linux. I've tested it on all three, and it is written 100% in Python. Okay, so a little bit about the structure here. Whenever you run commands in Build Magic, everything is bundled together into a job. And a job is composed of multiple stages. A stage is what actually runs commands and has this concept of a command runner and has optional setup and teardown methods. So what are these command runners? Well, this was kind of the key feature that I was thinking about when I wrote this that separates it out from a lot of other build utilities out there. So these command runners add a layer of abstraction that separate the commands that you want to run from where they actually run. So currently there's 4 of these command runners, the default being just run on the host machine. Also, there is a remote runner, which uses OpenSSH and public-private key authentication. It, theoretically could use password-based authentication. I just chose not to support it. It also there is the Docker runner. So you can specify a Docker image that you want to run all your commands inside. And Build Magic handles binding the volume and then doing Docker run and then tearing it down when it's done. And then last, you can run all your commands inside a virtual machine using Vagrant, if people still use Vagrant. So you there just specify the path to a Vagrant file, and Build Magic will run Vagrant up and then Vagrant destroy for you. So, okay, this is kind of what it looks like. Hopefully that looks okay up there. Yeah, it doesn't look too bad. All right, so on the command line, you run Build Magic. In this case, I've used the verbose option and then just a simple command, echo hello world. And you can see I've got a timestamp of when I ran it. I can see the command that was executed, and I even get the output from the standard out of that command. So, okay, this is fine, but it's just one simple thing, right? What if I want to batch a whole bunch of stuff to run? So the way we do that is what I'm just generically calling config files right now. So I know like Helm has Helm charts and Ansible has playbooks. I haven't come up with a clever name. I didn't want to call them like spells or like a spell book or anything like that. So we're going with the magic theme. So for now, they're just called config files. Honestly, if you can think of like a clever name, just email me and I might use it. So, okay, so we can batch stuff together and even run multiple stages using these config files. And it's just YAML. You can list out multiple stages. You can optionally give a name. In this case, I've said I want to use the Docker runner, and I want to run it inside an Alpine container. And I run 2 commands. Both of these are used for building a Python package. And then the second one will actually upload it to PyPI. So there are 2 keys before that, this build and release. So unlike some other systems like a GitLab CI or Ansible, these directives don't impart any actual meaning. They're purely what is it? They're there for just documentation purposes, for readability. So even though it says build on there, that doesn't actually mean anything. You can put something else there and it doesn't change what actually does. That's why I say that this is unopinionated, right? Build Magic doesn't care what you're doing. You just tell it what to do and how to, in what environment to run it in. So let's look at some common problems here. So problem 1. Developers on a team aren't always using the same operating system, hardware, version of Python, version of Go, etc., right? So I'm a big proponent of software teams should use what they're comfortable using and what they're most efficient in. But this creates a problem of when everybody's using, different operating systems, it gets hard to all work on the same thing. So that's where this concept of command runners and abstraction came from, because to address this, if you start thinking about, well, I'll run my commands inside Docker and then use build magic to automate all that, then I don't have to worry about, well, okay, this person is on a Windows laptop, so I don't necessarily need to, or I need to consider, do they have all the same packages installed? Do they have the same version? It's if it's all there inside a Docker container, then we're good in that sense. So kind of what this looks like whenever you run it, though, you can see some examples here of the different runners. These are all running Echo Hello World, but this shows you kind of what it looks like whenever you run it using the remote runner, the Docker runner, Vagrant. You get the idea. All right, so problem 2. The build process is often automated with shell scripts or extra Makefile targets, which are brittle and not portable. Okay, so that's kind of a bold statement, right? And I'm kind of opinionated here. Like, I know it's big, usually people are doing build automation with shell scripts and Makefiles. And I'm not talking about compiling my C or C++ program with a Makefile, like, please do that. I'm talking more about let's build a Docker image using a Makefile, or let's call npm test, npm build inside a Makefile. That kind of thing is more of what I'm talking about here. So let's look at an example here. So on the left, I've got a shell script. On the right, a Makefile, and they both do the exact same thing. I'm taking the string hello, writing it to file1.txt, the string world, writing it to file2.txt. Then I archive them using tar, and then I print created myfiles.tar.gz, and then remove the files. Okay, so that's pretty simple, but if you're looking carefully, you might notice there's a mistake up here. So the tar command is used incorrectly here. The arguments and the name of the archive file are switched. So when I run this, I get errors. So with the shell script, I get an error from tar, but after that, I still see it says created myfiles.tar.gz. It didn't do that because tar failed. So this is kind of a problem with shell scripts, is that even though a command failed, it continued to run afterwards. And that's not always what you want to do. Oftentimes, you want to just stop whenever you encounter a problem. And there's ways to do this in shell scripts. You have to build up some conditional expressions to check for status code, or you could use I think it's set-e maybe. I could be wrong about that, to kind of enforce the more strict execution. But then it's not as not so much of a simple thing anymore. So with the Makefile, whenever we run this, the Makefile stops when it encounters the error. But the problem there is I am removing the files in another Makefile target. So by doing that, that never runs and produces a side effect. Now even though it failed, I still have these files left over in the file system. So build magic handles this a little differently. So this is the equivalent using build magic. I use something here called an action, and this is the cleanup action. So what happens is whenever I specify this, build magic will scan the current working directory and know all the directories, all the files that are there, and then after it finishes running the stage, it looks at what new files are there and then removes any new files, new directories. So when I run this, I hit the error again, just like with the others. But the big difference here is that it did, execution stopped when it encountered the error, and it also removed file1.txt and file2.txt because I used that cleanup action. So this is nice because it becomes repeatable and it's not producing side effects whenever it runs. All right, so probably a lot of you are thinking like, why would I use this whenever we have, CI/CD, right? Because CI/CD does a lot of this stuff for us. Well, one common problem there is, as great as GitHub Actions and GitLab CI is, if you are automating in there, all of these are cloud-based. So if you get something wrong and you encounter an error, then you have to debug that and then start the pipeline again. And so then you could get into this loop of error, debug, retry over and over again because you can't do this locally. So really too, like if you're working for a company where they have a dedicated DevOps team, you might want to separate the concerns too of building the software from running the CI pipeline. So here I have a GitLab CI file where what it does is it downloads BuildMagic, installs it, and then runs it. So in this case, the application I'm building, just called My App, runs entirely inside BuildMagic, and then the pipeline doesn't care what's going on. That's the developer's concern to address that. So now we've separated the concerns there, and we're handling those things separately. Okay, so let's look at some examples of using this thing. So we can build a Python package using BuildMagic. In fact, this config file is the one that I actually use to build and distribute BuildMagic. So it builds itself. So it starts off by running Flake8. It runs unit tests. And then if all of that's passing, it will build the documentation, upload it to GitHub Pages, and then last it builds the wheeled file and then uploads that to PyPI. So before I used to have a shell script that did all of this. Now I just run buildmagic-c and then the name of the file is release.yaml, and that's it. I still use GitHub Actions for running unit tests for Python 3, 6, 7, 8, 9, 10, and checking code quality and coverage and that sort of thing. But this is the process for actually just uploading to PyPI when I'm ready to push a release. So example 2. This is something that I had to do when I was working at a startup, or it's based off of it. So I was responsible for maintaining open API specification for a RESTful API that we owned. And if anybody's familiar with Swagger or Open API, it produces these docs for you that they don't look bad. I can show you what it looks like here real quick. So you'll get a page that looks kind of like this, and you can drop down on this. You can see an example request body, example responses, and you get the idea. So the thing is, my boss doesn't like that. He didn't like the way it looked and liked the look of this other thing that I found out was called Slate, which is based in Ruby. So now I'm have to figure out, okay, how do I convert from Open API to Slate? Because I don't want to write all the Slate docs from scratch. So there's a utility called Widdershins that will handle the conversion, but it is an NPM package. And so I was like, I don't want to install all of this stuff just for doing this, right? So what I'm doing here is I build Docker images for Widdershins, for all of the Slate setup, everything I need. And that's what I do in this first stage here, is build my Docker images. And in the second stage, I just run the command to pull down the docs. And then, because it actually gets pulled down as, well, what it's doing is it gets pulled down all in one line. So I reformat it so it's at least nice looking JSON. The third stage is when I run widdershins, so that Docker image is running npm and stuff, and that converts it to a markdown file that Slate likes, which then I need to pass it to Slate, and Slate is very particular about how the file system is laid out and the names of files. But you can see here, I'm able to take care of that in just a few steps. And then I build my docs and get that back out. And, all of this happened in multiple Docker containers, but in the end, I'm able to get, just an index.html that looks like this. Make it a little bit bigger. All right. So this is the exact same docs now, just, produced using Slate. I can come down here and I can see stuff, but one thing that's nice is I get the code snippets over here on the side. So if I look at that, let's look at Python. It's using requests to do a lot of this. So that's cool. And yeah, I just did all that with Build Magic just a few days ago. So, all right, last example. So for a little while, I did some data science and data engineering work, and this example is an ML pipeline. So if anybody has used like Apache Beam, or if you've heard or used Metaflow or MLflow, anybody here an ML engineer? All right. Okay, a few use. Okay, so you kind of know what I'm talking about here then. One issue I've seen with those tools, especially like I think it's MLflow, you kind of have to build up all the code for the pipeline around the work the data scientists are doing. So you're like training the model in the same file where you're doing the pipeline, right? And so I was thinking, about this, and I was like, well, with Build Magic, actually, I can separate the concerns there. So, and this is nice because I can, separately work on ETL, cleaning data, feature extraction, training the model, and then deploying all separately from one another. And so I can have a data scientist do their part. I can have a data engineer worry just about ETL. And then, have DevOps or an ML engineer or somebody just worry about deployment, right? And then automate all of this with Build Magic. So that's, this is a very just, simple example here, but that's kind of what I'm doing here. So the first thing it does in this first stage is it downloads the wine quality data set and then calls etl.py. So in this case, etl.py, all it's doing is it's converting a CSV file to a feather file using PyArrow. And in the second stage is where I train my model. So that's all handled inside train.py, and I pass it some input arguments, give it my file name, I give it some parameters for the model, which is based in scikit-learn. And then I get a pickle file out, and just to try it out, like I GPG sign the model. So it's signed and encrypted. So I guess in theory, if you're uploading it to another machine, then at least, it's, where it came from. So all that kind of being said, there's a different syntax going on here, right? So you might see, I've got things like file name and server in like these double curly braces. So there's kind of a templating notation here going on with something I call runtime variables, where when I run Build Magic on the command line, I can specify, the name that I've templated out and then the variable that I want to substitute in at runtime. So every time I run this, I specify a new file name, and in the command up here, I'm setting the date time. So that way I have a timestamp of every time I'm running this thing. So then, the last stage here, I am removing the existing model, and then copying over the new one. I verify it and decrypt it, and then restart my server. So my web server is just a fast API server that just is also running scikit-learn and then serves up my model. So nice and easy, and I've separated the concerns of everybody involved along the way. So that being said, you know, some takeaways from this that I hope you have got from this is that, you know, Build Magic is going to help you automate tasks, and it's doing this by abstracting, you know, the command execution from the underlying host machine, and hopefully it does this in a better way than what you get with shell scripts and Makefiles. So also importantly, you know, this is designed in a way that it can evolve along with you and help you work the way that you want to work. So that being said, you know, Build Magic still, it's beta, it's still under active development. I have a feature roadmap that, you know, I'm working on, and I could use some help too. So, you know, if you're interested in open source software or are looking to get involved with the open source software, and maybe you find this interesting, you know, please reach out. Here's where you can find the project on GitHub, on PyPI. All the examples I showed today are in their own repo called Build Magic Examples. You can find the docs at, I've got kind of this emoji URL. It's the hammer sparkle robot.y.at. So if you want to try that out, I mean, everything I've tried it out on, it works, except for LinkedIn. So, and that's not entirely true. It works on LinkedIn on the web, I think, but not mobile. But anyway, so thank you for putting up with listening to me, and you know, I can maybe take a few questions if there are any real quick.